Hey guys, welcome to Easy Chemics. Today I am going to discuss about atomic and molecular structure and the questions regarding these chapters. So first I will talk about the JAM to the previous year questions, last 5 years questions, and then I will talk about the questions you may face in JAM 2019 regarding those questions, right? So the first topics in atomic and molecular structures are the fundamental particles, Bohr theory of hydrogen-like atom, wave particle duality, uncertainty principle, Schrödinger wave equation, quantum mechanics and especially quantum numbers, shapes of orbitals, Hund's rule, Pauli's exclusion principle, and electronic configurations of simple homonuclear diatomic molecules. Right. So the first question in JAM 2014 was the energy of an electron in a hydrogenic atom was with nuclear charge Z varies as, that is En varies as with Z. How? From the energy equation you can easily determine this. Then this will be if En proportional to Z square. So this is the very simple question, and this type of question you will face in JAM 2019 also. So JAM is not quite tough, just it's different, right? So the second question in 2014 was there is a mathematical problem, right? Eigenvalue problem. It's like and you have to calculate the value, and finally you will get the C value is alpha by m, right? So you can easily calculate this, this question is not that much important. Okay, so just you can ignore this question also. So these two questions came from JAM 2000 came in JAM 2014, and in JAM 2015 the first question was the ground state term symbol for a free ion having 3d7 electronic configuration. 3d7 electronic configuration, and the answer will be A4 9/2. This will be the correct answer. Okay, and how can you calculate this? You can first calculate n value, then l value, then ml value, and finally j value. From these 4 value you can easily calculate this. If you cannot, then just leave a comment in the description box and in the comment box, and you will get a video on this tonight, right? So the second question in JAM 2015 was just hold a second, was the value of px cap x cap minus x cap px cap. What will be the value? Just put the value of px cap, that is h by 2 pi I del by del x, and puts the value x, and then take a function and easily calculate this value. This problem comes like this: p x comma x. This is a commutator value, and you have to calculate the value of this commutator. Okay, this is equal to this. So the final value will be h cut by I or I h cut. Both are same actually. So these two will be the same correct answer. This is a MSQ type question. So I want to tell you something, that whatever I am teaching in this today, right? So you will get everything in the PDF format in the link given in the description box. Also I have started a blog, so you can check this over there, and you will get the link in the description box, right? Okay, come to the point. So these two questions was in JAM 2015, and then coming to JAM 2016. Okay, in JAM 2016 the first question was the effective nuclear charge of helium atom is 1.7 electron volt. The first ionization energy, sorry, not electron volt, just 1.7, and the first ionization energy of helium atom in electron volt. What will be the first ionization energy of helium atom? And from the equation you can easily calculate this value, and this value finally will be 39.3 electron volt. Okay, so what equation you should use? Just use energy equation, Bohr energy equation. Okay, and then the second question was in JAM 2016 3pz orbital, and what is the radial and angular node. So radial node formula is n minus l minus 1 and angular node is only l. So from here you can calculate the n value equals to 3, l value equals to p orbital for 1, and from this n minus 1 value will be 1 and l also 1. So the answer 1 radial and 1 angular node, the correct answer, right? So the second question, the third question comes in JAM 2016 from this chapter is the bond order of Be2 molecule. From this MO diagram you can easily calculate the bond order of Be2 molecule, which will be 0, right? This is actually an inorganic question, and you will face this question as physical also, right? Okay, so the answer will be 0. Okay, next coming to JAM 2017 question. Okay, so the question is from particle in 1D box, and the question was for a particle in one-dimensional box of length L with potential energy Vx equals to 0 for x less than L less than 0, and potential energy Vx equals to infinity when x greater than equals to L or x less than equals to 0. An acceptable wave function of consistent with the boundary condition is. So you can see the question on the screen, and the final answer will be the one from the fourth option. Okay, so you can easily calculate determine the answer. So how can we calculate this? You will just verify the equation, the boundary condition. So when x equals to 0, psi should be 0. When x equals to L, psi should be 0. So these two conditions, which of the following equation will satisfy, and you will put the value x equals to 0 and x equals to L, and you can see the equations, the option C, that is c x cube x minus L. This equation will follow the both condition. If you put the value of 0 of x and if you put the value of x is L, both value will be 0. So C is the correct answer. So the second question is from this to the JAM 2017 was the wave nature of electromagnetic radiation is observed in fourth option: diffraction, interference, photoelectric effect, and Compton scattering. And you know very well that the wave nature shows in diffraction and interference. So these two will be the correct answer, right? Okay. Now coming to JAM 2018 question. So JAM 2018, the very easy question was. So the question is, which of the following sets of quantum numbers are or is not allowed? So the answer will be n equals to 4, L equals to 0, ml equals to minus 1. So why is this? Because n equals to 4, that is n 4, L 0, that is s orbital, ml equals to minus 1. For s orbital, for L equals to 0, ml cannot be minus 1. So this is not acceptable. And another, n equals to 3, L equals to 3, and ml equals to minus 3. So when n equals to 3, n cannot be 3, because L value will be 0 to n minus 1, that is 0 to 2, 0, 1, 2, not 3. So this also be the incorrect answer. So incorrect options. So these two will be the correct answer. Okay, B and C. Okay, so the second question was in JAM 2018, the electron of a hydrogen atom in its nth Bohr orbit having de Broglie wavelength 13.4 Armstrong. The value of n is what? You need to calculate the value of n. So you just use the value n lambda is equals to 2 pi r. R is the radius, and radius you are given to the lambda value, and you need to calculate the n value. Okay, so you know the first Bohr radius, that is 0.53 Armstrong, and lambda value that is given 13.4 Armstrong. So from here you can easily calculate the n value, and this will come as 4, right? So 4 is the correct answer. So this type of questions you will face in JAM 2019 also. These are the very easy questions, and with these questions I will add some important topics from these options, from these questions regarding JAM, previous year JAM questions. Okay, so the topics are Bohr theory, and you need to remember the different equation from Bohr theory, then eigenfunction and eigenvalue along with the Schrodinger equation, then particle in a box. This is very important, very important. You can face this type of questions. I mean these the boundary condition type questions. Okay, so another important is de Broglie equation and its mathematical formulation, then quantum numbers, then ground state energy, term symbols, and Hund's rules. These three are interconnected. Number of node calculation. Okay, and finally the bond order. Though you can know it from inorganic chemistry also. Okay, so along with this, my suggestion will be you have to remember all of these things which are mostly important, not only the based on the previous year question papers. Okay, so my suggestion will be add some another things, or whatever you will teach. You will be teaching in BSc third year examination, third year syllabus. Okay, and from this just add something, and I am telling you all of this: commutator and commutation. And I have made already a video on this commutator and commutation. Search on my channel as Heisenberg uncertainty principle. You will get it over there. Okay, then linear and non-linear operator, then Hermitian operator, average value or expectation value calculation, then normalization constant calculation. This is a very important topic, normalization value calculation, normalization constant calculation. Then orthogonalization. These two, there will be given two wave functions, and you have to verify these two are orthogonal or not. Then RDF graph, radial distribution function. Okay, and from that you need to calculate the number of nodes from that graph. This will be an important question, maybe important question in JAM 2019. Then particle in cubical box, not one dimensional, a three-dimensional cubical box, and from here they can say to calculate the degeneracy. Okay, then basic MO from hydrogen to F2. You can calculate, Ne2, neon 2, hydrogen, helium, lithium, everything, just hydrogen to neon. They're very easy, but you need to calculate, because from here you can face some questions like magnetism, paramagnetism, or diamagnetism, or you can need to calculate bond order, as you have seen that in the previous year they gave some questions on this. Okay, so these topics are very important, and if you clear all this topic, then I am sure from this chapter you will not miss anything. Okay, so just follow this type of topics, and if you have any problem or any topics you need to understand, just comment below, and I will definitely make videos on this. And you have a comment in the blog also, in my blog also, so that it will be very easy for me to answer you. Okay, so thanks for watching. Okay, bye bye.